Algebra, welcome to our third video, 7.3 Rational Exponents. And I took a couple of notes that you may want to take note of. Make sure you have this 7.3. We're going to do the odd ones together. And then make sure you have maybe some paper to write notes or not. Anyway, a couple of things I wanted to go over with you is that radical form means in the root, square root, cube root, but under the root sign. So any number under the root sign is called radical form. So 4 in radical form is the square root of 16 because the square root of 16 is 4. So that is 4 in radical form. 4 in exponential form is 4 to the first power. You could also do 2 squared, but I just kept it simple with 4 to the first power. So if we're talking about radical form, we are talking about in the square root sign or in a root sign. If we're talking about exponential form, we're talking about a base with an exponent. Rational exponents. Rational means that the exponent is a fraction. So if you've got an exponent that is a fraction, your numerator is raised to a power. The denominator is the root, okay? So let's look at 2 examples. 25 to the 1/2 power. So the root needs to be the second root, which is your square root. So you're going to put 25 under the square roots and then raise it to the first power. So the square root of 25 is 5. 5 raised to the first power is 5. So 25 to the 1/2 power is 5. Let's look at a different one, 27 to the 2/3 power. Well, the denominator, again, is your root. It is a 3 in the denominator. So instead of a square root, we've got a cube root. So we're going to take 27 and find the cube root of that. The numerator is then what power it is raised to. So you're going to find the cube root of 27, and you're going to raise it to the second power. Well, the cube root of 27 is 3. 3 raised to the second power is 9. Okay? So I just wanted to go over quickly with you rational exponents. Your calculators have the capability to use a rational exponent. So it will do the work for you, but I wanted to show you where it comes from. All right, so let's look at our assignment today. And the first part says, write each expression in radical form or write each radical in an exponential form. So we're flip-flopping between the 2 forms. So this right here is an exponential form. We need it to be in radical form. So again, the denominator is the radical raised to this power. So what we're going to do is we're going to take 8x and we're going to put that under the square root sign, and it's raised to the first power. Again, the 2 is the square root, the 1 is raised to the first power. This, however, is a little bit redundant. We don't really need to the first power, so we are just going to write the square root of 8x. So 8x to the 1/2 power is the square root of 8x. Now, 13 says square root of 19. We need to turn it into an exponential form. So what we are going to do is we're going to take 19. This is understood to be raised to the first power. So the exponent is going to be 1/2. It is the square root. So we put a 2 there to designate the square root. It is understood to be to the first power. So we're going to put the first power. All right, let's look at number 5. 19x to the 1/2 power. One thing I want you to understand is 5 and 1 are different. Because 8x is in parentheses raised to the 1/2 power, that is what we are going to put in the square root, in the root. This one's different. 19 is not part of this. X to the 1/2 power, the 1/2, the exponent of 1/2 only goes with the x. It doesn't go with the 19. If it did, there would be parentheses. So this is going to be 19 times x to the 1/2 power. Well, 1/2 power is the square root. So it is going to be 19 times the square root of x. Okay? Let's look at 7. 7 is in radical form, and we need to make it in exponential form. Now notice that 27 and g are under the square root sign. So I'm going to need to group 27 and g together. And anything time you take the square root, the exponent would be 1/2. Okay? Let's look at number 9. Same thing. We've got this big group under the square root sign. So I need to group these together in exponential form, and we group them together with parentheses. 13, A, B, C, and the square root, the exponential form would be to the 1/2 power. All right, let's look at the second part, which is simplify. Simplify. You may use a calculator for this. I don't mind it. So I've got my calculator ready to go. So simplify number 11. This is the 5th root of 3,125. So remember to find the 5th root, you are going to access this key, second, I think you put 5, second, I think that's right, 3125, 3125, enter. All right, so the 5th root of 3,125 is 5. So we are going to put 5. All right, 13 is 1 over 32 to the 1/5 power. You could actually use your calculator for this. So we are going to do, I would put it in parentheses, 1 over 32. Whoops. 1 over 32 out, raised to the 1/5 power, 1/5. It's quite a lot of keys, but you've got it. 1/32 to the 1/5 power, enter, and it equals 1/2. Okay. 15, 1,024 to the 1/5 power. Just so that you know that we could also do the 5th root of 1,024. Either one of these will work. Let's see if I can prove that. Let's clear that. All right, 1,024 raised to the 1/5 power, enter, is 4. And I'm just double checking it. 5, the 5th power of 1024 is also 4. So see, it works both ways. All right, 17, the 6th root of 15,625. So we are going to do the 6th root of 115,625. Enter is 5. All right, make good use of your calculator on this. All right, let's look at the bottom part. The bottom part is a little bit different. It is solve each equation. So you are going to figure out what the exponent is. What I would do, to be quite honest, is just guess and check. I have tried to kind of figure out how to do it without guess and check, and if there's a way, I don't know what it is. So we're going to guess and check. So 2 raised to what power is 512? So I will just try 2 raised, let's say, to the 4th power. I know that that's not it, is 16. All right, I'm way off. 2 to the 8th power. Oh, 256. All right, I'm getting closer. Now 512 is twice that much. So I think I would multiply this by 2. So instead of 2 to the 8th, let's try 2 to the 9th, 512. Okay. The power needs to be 9. So x equals 9. Let's look at 21. 6 to what power is 46,656? All right, so let's do some guess and check. 6 to what power? Let's say 6 to the 6th. Oh, I got it. First try. 6 to the 6th is 46,656. So my exponent needs to be 6. So x equals 6. All right, let's look at 23. This one's a little different. I've got to figure out what my exponent is first, and then I'll work on this. So 3 to what power is 243? So let's try, I'm going to clear 3 to the 4th power. Nope. 3 to the 6th power. Oh, 3 to the 5th power. 243. All right, it is 3 to the 5th power. So I need this to be to the 5th power, but it's not just an x there, it's x minus 3. I need x minus 3 to equal 5. Well, in order to make this work, x has to equal 8. So in this case, x is 8. Even though we needed 5 to be our exponent, since it's not just an x, but a little expression here, we got to figure out what value of x makes the equation of x minus 3 equal 5 true. All right, let's look at 25. There's another one. Similar thing. I've got a little expression here. I got to see what do I need it to equal. So 6 to what power is 1,296. So 6 to the 5th. I don't remember. Okay, that's way off. 6 to the 3rd. Oh my gosh. 6 to the 4th. There it is. 6 to the 4th is 1296. So I need x minus 1 to equal 4. So we will write x minus 1 equals 4. Well, x has to be 5 in order for that to be true. All right, last one, 27. 3 to some power needs to be 6,561. Too much stuff all over here. All right, let's try that. What is 3 to what power? All right, 3 to the 6th power? 729, way off. 3 to the 9th power? Oh, way off. 3 to the 7th? I think it's to the 8th power. 3 to the 8th power. Yep, 3 to the 8th power. All right, so 3x plus 3 has to equal 8. 3x plus 3 has to equal 8. So I'm going to subtract 3 from both sides. So we've got 3x equals 5. Divide both sides by 3, so x has to equal 5/3. X to the 5th 5/3. All right. There we go. So this is working with rational and exponential form. Try the rest on your own. I do have office hours, so if you need to give me a call, give me a call. And good luck, class, and I'll talk to you soon. Bye. Let's see.